What is a manometer?
An instrument used to measure pressures of gases.
What is an acid?
A molecule that has easily removable hydrogen ions, Brønsted-Lowry acid. Can accept a pair of electrons, Lewis, or releases hydrogen ions in solution, Arrhenius.
What is a filtration?
The process of removing any solid particulates from a solution.
What is meta?
Term used to describe two substituents on an aromatic ring that are separated by one position. I.e., 1,3 substituted.
Why do hard-boiled eggs spin, while raw eggs don't?
Hard-boiled eggs are solid all the way through, so when you spin the egg, all the energy you apply goes into spinning the whole object. Raw eggs have yolks that are free to move about the interior of the egg, however. So when you spin a raw egg, the yolk moves to the outer edge of the inside of the egg, which consumes some of the energy you applied. The other difference you can see is what happens after you stop these two eggs from spinning. Stopping the hard-boiling egg stops the entire system. Because the yolk is trapped in the solid, cooked egg white. Inside the raw egg, however, even after you stop it, the yolk is still spinning around. So if you take your finger off of a raw egg that was just spinning, it can start moving again, seemingly on its own.
How many elements are there, and will more be discovered?
As of the writing of this book, 118 elements have been discovered. The lightest element, with only one proton and an atomic mass of 1.00794 g/mol, is hydrogen. The heaviest is ununoctium with 118 protons and an atomic mass of 294 for the only detected isotope. Considering that 5 new elements have been discovered since the year 2000, it seems very likely that more elements will be discovered. It is getting harder and harder for scientists to discover, or synthetically create, new elements, though, because the heaviest elements that have been observed to date are usually unstable and decay extremely quickly.
What is an electric current?
Electric currents are the flow of electrons through a material. The electricity that comes out of the wall in your home or office is just the flow of electrons through a wire.
What is a triple point?
The temperature and pressure at which three phases of a substance are in equilibrium is known as a triple point. The three phases can be solid, liquid, and gas, but can also be two solid phases. Different arrangements of the molecules in the solid and a liquid phase.
What is fire?
The chemical description of fire is a combustion reaction. It involves the reaction of oxygen with molecules in some combustible material. The fire itself is caused by energy released by this reaction in the form of heat and light. The fire you see is not only the light that's being released, but also glowing hot gases.
What is an example of how to green a chemical process?
At the pharmaceutical giant Pfizer, the synthesis of Viagra, see the world around us, originally had an E factor of 105. However, even before Viagra, was made available to the public, a team of researchers at Pfizer re-examined the entire synthesis step by step. Relatively toxic chlorinated solvents were replaced with less toxic alternatives. The synthesis was also modified to recycle the solvents wherever possible. The use of hydrogen peroxide, which carries some associated health hazards, was removed from the process. Another reagent, oxalyl chloride, is also no longer used. Use of this reagent results in the production of carbon monoxide, which is now avoided. In the end, the E factor for synthesis of Viagra, was reduced to only 8, an over 13-fold reduction. Subsequently, similar changes were made to processes throughout Pfizer. The E factor for Lyrica, an anticonvulsant drug, was similarly reduced from an initial value of 86 to now only 9. These sorts of improvements are eliminating millions of tons of chemical waste, while in most cases simultaneously lowering production costs, making safer work conditions, and making products safer for consumers.
Can light move through a vacuum?
Yes. Unlike sound, light is an electromagnetic wave, so no molecules are needed to propagate the wave. But you knew this: the sun's light crosses the vacuum of space to reach Earth each and every day.
What are some chemical reactions that we can observe with our naked eye?
There are lots of chemical reactions that we can easily detect by sight. Some examples are the formation of rust on metal, wood burning, fireworks exploding, silver becoming tarnished, or baking soda and vinegar reacting with one another.
What is a biosignature?
A biosignature is a chemical signature that can be observed from a distance that signals the presence of living organisms. These could include complex chemical structures associated with life forms or accumulated quantities of biomass or waste.
Why did Walter Norman Hayworth, United Kingdom, win the Nobel Prize for Chemistry?
For his investigations on carbohydrates and vitamin C, and Paul Karrer, Switzerland. For his investigations on carotenoids, flavins, and vitamins A and B2. Hayworth's work on carbohydrates expanded on that done by Fischer, making significant further progress into understanding the structures of various isomers of monosaccharides and disaccharides. Prior to this work, very little was known about vitamins, carotenoids, and flavins. And these men were the first to uncover the chemical composition of these molecules. In addition to his work with sugars, Hayworth also studied the composition of vitamin C. Karrer shared the prize for his work characterizing the chemical compositions of several carotenoids and flavins, as well as vitamin A and vitamin B2. Knowledge of the chemical compositions of these species provided some of the earliest insights into how they are formed and the roles they play as nutrients in the human body. Prior to their work, little was known regarding the chemistry or reactivity of these species. Because their composition was not known.
Why does the inhalation of helium make voices higher?
After you inhale helium, your voice might sound higher, but the pitch or frequency of the sound waves is exactly the same. Your vocal cords vibrate at the same frequency because your body doesn't adjust for the presence of a less dense gas in your throat. What does change is the speed of sound in helium versus air, because helium has a lower molecular weight than air, the speed of sound is higher. You've probably heard this is because helium is less dense. That's not technically correct, but let's not go there.
What will happen to the gum I just accidentally swallowed?
When you were a kid, your parents or teachers probably told you, or at least they told us, not to swallow your chewing gum because it would take years to digest. Actually, your body can do just fine with digesting the flavor components, sugars and sweeteners, and softening ingredients in chewing gum. It's only the gum base that you cannot digest. However, just because you cannot digest it does not mean it will stay around in your body for several years. The gum base will just typically pass through your digestive system in just a few days' time. But please don't try to swallow a bunch of gum at the same time, though it can get stuck and cause all sorts of problems.
What is crude oil?
Crude oil is the oil that is found underground in natural reserves. It is formed from the natural decay of living things that were in the sea millions of years ago, which is why it's commonly called a fossil fuel. The key ingredient that makes oil a valuable energy source is hydrocarbons. As we discussed briefly in chemical reactions, hydrocarbons release substantial amounts of energy when they undergo combustion reactions.
What is an elastic material?
A material that deforms when an external force is applied, but returns to its original shape when the external forces are removed.
What is an oxidant?
An oxidizing agent, or a species that removes electrons from another species.
What is an unsaturated compound?
A molecule with at least one pi bond or ring structure.
What is a Lewis acid?
A molecule that can accept a pair of electrons.
How does an atomic bomb work?
Atomic bombs, A-bombs, are based on nuclear chain reactions that occur very rapidly, causing a huge release of energy in a very short amount of time. In early designs, two pieces of uranium would be fired at one another in the core of the bomb, initiating the fission chain reaction responsible for the explosion of the bomb. As the bomb starts to detonate, the core of the bomb expands, and it is necessary that pressure be applied against the expanding core while the fission process takes place. Within a fraction of a second after detonation, the explosion takes place. These are the type of bombs that were used at Hiroshima and Nagasaki in World War II and are the only nuclear weapons that have been used in war to this day.
What is an X-ray?
a form of short-wavelength electromagnetic radiation.
What is the third law of thermodynamics?
The most common statement of the third law of thermodynamics is that the entropy of a perfectly crystalline system approaches zero as the temperature of the system approaches zero. Recall from macroscopic properties. The world we see that a perfect crystal is a regularly ordered lattice of atoms that exist in a repeating pattern in 3 dimensions with no defects or irregularities in the lattice. This is equivalent to saying that a perfectly crystalline system has only one accessible state as the temperature approaches zero. In truth, this isn't always strictly true since there can be multiple low-energy states that all have the similar energy, but let's ignore this for now.
What is precipitation?
Precipitation is the formation of a solid in a solution. This happens when a substance has too low of a solubility to remain dissolved in the solution. This process can occur for a variety of reasons, such as when a new product of a chemical reaction has low solubility or when a temperature change takes place. Precipitation begins when a small crystal begins to form, which is part of a process called nucleation.
What are the transition metals?
Elements in the D block, groups 3 to 12, of the periodic table are referred to as transition metals. The lanthanides and actinides are usually excluded. With the exception of group 12, the transition metal elements have an incomplete d shell of electrons. The chemistry of these elements depends strongly on these d electrons. And most transition metals are stable in multiple different oxidation states. If the metal has any unpaired d electrons, it can have magnetic properties. Many transition metals have uses as catalysts in bond-forming reactions. And we'll talk about a few later in this chapter.
What is a surfactant?
A solute that reduces the surface tension of a liquid.
What is potential energy?
Potential energy describes all of the non-kinetic energy associated with an object. This energy can be the energy stored in chemical bonds, in a compressed spring, or in a variety of other ways. Another example is gravitational potential energy, like that associated with a ball sitting at the top of a hill. Since there are many types of potential energy, there isn't a single equation that describes them all. Since the value we assign to potential energy is always inherently described relative to some choice of a reference value, we can only actually measure changes in potential energy in a meaningful way. A closed system can exchange potential energy for kinetic and vice versa. But the total energy must always remain constant. This is stated in the first law of thermodynamics, which we'll get to soon.
What is a glass?
An amorphous solid material.
What is an amplitude?
The height, or maximum displacement, of a wave.
What is molecular weight distribution?
We just talked about the fact that polymers can have different molecular weights. Oftentimes in reactions that make polymers a range of molecular weights are produced. The molecules may be composed of the same repeating unit, monomer. But for a number of reasons the chains are different in length. It turns out that this distribution of lengths is important to a number of polymer properties. The details of how this number is calculated are not worth going into. It's sufficient to know that a higher molecular weight distribution means that there is a larger spread of polymer chain lengths. A distribution of 1.0 would mean that every single polymer chain has the exact same molecular weight.
What is isothermal?
With constant temperature.
What is a bimolecular reaction?
A reaction that involves two molecules in the rate-determining transition state.
If fracking is an old technique, why does it seem to be taking off now?
The second key innovation that has allowed fracking to grow so fast in recent years is the ability to drill wells horizontally. Technically, any well that isn't vertical is called directional or slant drilling. Hydraulic fracturing can release trapped natural gas from a much wider area this way, which has led to the recent surge in this technique.
What is a sigma bond?
A chemical bond involving direct overlap between orbitals on adjacent atoms. Sigma bonds are symmetric with respect to rotation around the bond axis.
What is an auxiliary substance?
Chemical auxiliaries are substances like solvents, separation agents, or dispersing agents that are used in the course of a chemical synthesis but are not reagents because they are not incorporated into the chemical product.
What gives a substance its color?
The color of a substance is the combination of the light that is reflected back at your eye. In other words, you're seeing the light that is not absorbed by the substance. Certain frequencies can be absorbed because of the electronic structure of a substance, while others simply bounce off back into your eye.
What is a coulomb?
The standard unit of charge, defined as the amount of charge delivered by 1 amp in 1 second.
What does infrared, IR, spectroscopy measure, and what does it tell you about a compound?
Infrared spectroscopy measures the absorption of light by molecules in the infrared region of the spectrum, which provides information on the types of functional groups present in a molecule. For example, looking at the infrared spectrum can provide evidence as to whether certain pairs of atoms are bonded by 1, 2, or 3 pairs of electrons. The shapes of the peaks in an infrared spectrum can also be used to gain information about intermolecular interactions between the species we are looking at and the surrounding medium.
What is freezer burn?
Freezer burn occurs when frozen food undergoes dehydration due to improper packaging. The humidity level in a freezer is usually quite low, so if food is not stored in airtight packaging, water in the food can be drawn out into the freezer atmosphere by sublimation. Also, because the food is exposed to air, oxidation can occur. Though at the lower temperatures in a freezer, these reactions are quite slow. Thankfully, although freezer burn looks nasty, it's not a food safety concern, it just causes discoloration.
What is a melting point?
The melting point is the temperature at which a substance changes from the solid state to the liquid state. At this exact temperature, the two phases are in equilibrium. So fractions of the sample are constantly moving between the two phases of matter. In practice, it is pretty difficult to observe the exact melting point of a substance.
What is materials science?
Materials science is a field at the intersection of the basic sciences and engineering, with a focus on the relationship between the microscopic, atomic or molecular, structure of a material and its macroscopic properties. Many techniques relevant to chemistry are used to characterize materials, and the descriptions of the underlying microscopic structure of the material are discussed with regard to solid-state chemistry. Thus, many components of materials science represent applications of chemistry. In this section we will provide a brief introduction to materials science, with a focus on some of the topics that are more relevant to chemistry.
What is a spectrum?
A plot of the absorption intensity of light by a sample as a function of wavelength.
What is biodiesel?
Biodiesel is a type of fuel made from vegetable oil and or animal fat which consists of long alkyl esters. See organic chemistry to review functional groups. Biodiesel fuel is commonly distributed for sale as a mixture with petrodiesel, and is labeled with a B factor describing the fraction of biodiesel present. B100 is pure biodiesel, while B20 would represent a mixture of 20% biodiesel with 80% petrodiesel.
How are metals important in maintaining osmotic balance in cells?
The metals sodium and potassium, really they're ions, Na and Nk+, are responsible for moderating ion and concentration gradients across cellular membranes. These ions can be selectively allowed to pass, or be pumped, across cellular membranes.
Why does lemon juice prevent fruits from browning?
If you put lemon juice on your fruit after cutting it to prevent browning. This is an example of that last category of preservative, one that slows some enzymatic process. The vitamin C lowers the pH, because it is an acid, slowing the enzymes. Polyphenol oxidases and tyrosinases, that cause browning of your fruit.
What is isobaric?
With constant pressure.
What is bronze?
Bronze is an alloy of copper and tin that may contain up to 1/3 tin. Early civilizations used bronze because it could make stronger, more durable tools than stone or pure copper.
What is carbon sequestration?
Carbon sequestration and carbon capture are processes to remove carbon dioxide, CO2, from the atmosphere and store it. This is exactly what plants do when they convert CO2 into other molecules like sugars and proteins. Carbon dioxide can also react with water and limestone, CaCO3, to form calcium bicarbonate. Ca, HCO3, 2, in an inorganic example of natural carbon sequestration. Generally, though, this term is used today to refer to man-made processes for removing CO2 from the atmosphere or for capturing it before it gets released, like from power plants. A number of approaches to long-term carbon dioxide storage are being, or have been, tried, including pumping the gas deep underground into natural rock formations, scrubbing the CO2 out from flue gas by reacting it with bases, or transforming the CO2 into other useful molecules for making polymers, just to name a few.
Why did Irving Langmuir, United States, win the Nobel Prize for Chemistry?
For his discoveries and investigations in surface chemistry. As a graduate student, Langmuir studied light bulbs, and then went on to improve vacuum pump designs. These two interests merged, in some respects, and Langmuir was able to invent the incandescent light bulb. These led to his interest in surface chemistry, after observing that a tungsten filament, like those in a light bulb, could split H2 on its surface, forming a single atomic layer of hydrogen atoms. The work of direct relevance to his receiving the prize, however, was his study of thin films of oil and surfactants on the surface of water. Langmuir postulated that the molecules of surfactants would orient themselves into a layer that was a single molecule thick. He went on to develop the physics to describe such thin layers, which would eventually be known as monolayers.
What is the role of photochemical reactions in green chemistry?
Photochemical reactions can often serve as excellent choices for green synthesase. One reason for this is that a photon, unlike chemical catalysts or reagents, leaves behind no waste or excess atoms. Photochemically initiated reactions can often proceed rapidly at ambient temperatures. Since photoexcitation can be used to generate highly reactive species. In some cases, photochemical synthesase can also reach the synthetic target in fewer steps than those which rely on thermally initiated reactions.
What kinds of safety precautions are typically taken when working in a chemistry laboratory?
Chemists working with chemicals in a laboratory typically wear safety goggles to protect their eyes. a lab coat to protect their skin and clothes, and a pair of gloves to protect their hands. Of course, there are many situations when additional specialized protective gear is necessary.
How can I show my friends a magic trick using pepper?
Chemistry principles encountered in this experiment: polarity, surface tension, materials you'll need: a shaker or small packet of black pepper dishwashing soap, a few drops; bowl water, a bowl full. The procedure: begin by filling the bowl with water. Then pour black pepper onto the water to form a thin layer of pepper across its surface. As a control experiment, try dipping your finger below the surface of the water. Nothing too interesting should happen at this time. Now rub a small amount of dishwashing soap on your finger and dip it in the water again. This time, you should see the pepper move away from your finger and toward the edges of the bowl. The nonpolar soap molecules don't want to dissolve beneath the surface of the water, and thus they spread across the surface of the water quickly, which lowers its surface tension. Whereas water typically bulges a bit above its surface due to its relatively high surface tension. The water spreads out when its surface tension is lowered. This causes the water to spread out as the soap moves over it, and the pepper is carried away from your finger in the process. Now that you understand the basics of this trick, you can perform it for your friends. Ask a friend to dip their finger in the water and to try to concentrate on trying to make the pepper move away from their finger. When they cannot make it happen, you can step in and use your already soapy finger to easily move the pepper away.
What is a reversible reaction?
A reaction where the products can be converted back into the reactants.
What is a bond order?
Number of pairs of electrons shared by two atoms.
What is HDPE, high-density polyethylene?
High-density polyethylene is technically any polyethylene with a density of 0.93 to 0.97 g/cm3. The density in polyethylene is controlled mostly by the number of branch points along the polymer chain. HDPE has very few branches, so the chains can stack together very closely. This tight packing makes it a very strong polymer. So it's used to make things like bottle caps, milk jugs, and hula hoops.
What are the alkali metals and alkaline earth metals?
The first two columns of the periodic table are known as the alkali, group 1, and alkaline earth, group 2, metals. The elements in both groups have very low ionization energies, which means they readily give up 1 or 2 electrons to reach a noble gas electron configuration, example Na+, Mg2+. In their elemental forms, these elements are soft, silver-colored substances. These elements are almost never found in their pure elemental state in nature because they quickly react with air or moisture, sometimes violently.
What are the different groupings for elements on the periodic table?
There are several ways of classifying the elements on the periodic table. One is by the periods, or the horizontal rows, in each of which the properties of the elements change going from left to right. Another common classification is by groups, or vertical columns on the table. All elements in the same group are expected to have similar properties, which is the periodic property, originally noted in the law of the octaves, after which the table is named. Yet another classification is by blocks, meaning the elements are classified by the type of orbital in which the highest energy electrons reside, see below. The logic behind this type of classification is that the type of orbital in which the highest energy electron resides strongly influences the reactivity of the element. Thus elements in the same block usually have similar properties. There are even more ways still of clustering the elements on the table, but these three are the most commonly used.
What is a salt bridge?
A method used to place the two sides, solutions, of an electrochemical cell in electrical contact.
What is the Hess's law?
States that the change in enthalpy for a reaction that occurs in multiple steps is equal to the sum of the change in enthalpy for each step, related to the first law of thermodynamics.
What chemicals are commonly found in mosquito repellent?
A chemical known as N,N-diethylmethyluamide, more commonly known as DEET, is the most commonly used insect/mosquito repellent. This chemical can be applied directly to the skin to prevent mosquito and other bug bites. It is believed to work because mosquitoes dislike the smell of DEET, so they try to stay away from it. In some cases DEET can be an irritant and, in very rare cases, it has been associated with more serious health problems such as seizures.
What is a thermoplastic?
if a polymer becomes soft when it is heated, and then hardens again when cooled, it's known as a thermoplastic. The temperature at which the polymer softens depends on what it's made of and on the size of the polymer chains. Thermoplastics are easy to recycle because they can be remolded when they're hot.
How is analytical chemistry used in medicine?
Analytical chemistry techniques are routinely used in many areas of medicine. When your blood is drawn, for example, the doctors use techniques borrowed from analytical chemistry to determine levels of several analytes in your body, including cholesterol, vitamins, glucose, and white blood cells. Analysis of tissue samples and other biological fluids is also based on analytical techniques. Other examples of medically related applications include tests for illegal drugs and steroids. Glucose sensors used by diabetic patients, or to check for toxic substances in your body if you are exposed to hazardous chemicals.
Why does my chocolate turn white when I wait too long to eat it?
Chocolatiers refer to this as a bloomed chocolate, which is a wonderfully obscure and appealing way of describing the white stuff that forms on old Halloween candy. There are two processes that could be happening here, either sugar bloom or fat bloom. Sugar bloom is the candy world's way of saying sugar crystallization. If your candy is exposed to moisture, sugar molecules dissolve out of the fat in the chocolate, and once that moisture evaporates, the separated sugars have a chance to crystallize. If your candy has stayed dry but underwent a quick temperature change or was stored warm, it's probably fat from the cocoa butter that has separated from the chocolate. In either case, it is usually still fine to eat.
What are the lanthanides and actinides?
The actinides and lanthanides make up the F block of the periodic table. These two rows are frequently separated from the main table. But that's just so the periodic table isn't so wide on a piece of paper, seriously. Many of these elements have radioactive isotopes, but the rate at which they decay can vary immensely. For example, 238U has a half-life of 4.5 billion years. But 234Pa has a half-life of only 72 seconds.
What is absorption?
Attachment of one substance to another, see absorption and adsorption.
What is the role of aqueous hydrogen peroxide as a green reagent?
Hydrogen peroxide, or H2O2, is an ideal choice for a green oxidant because it reacts with high atom efficiency and can react to produce water as the only byproduct. To be a particularly clean oxidant, hydrogen peroxide can be used in aqueous solvents, allowing chemists to avoid the use of any organic solvents. Fortunately, there exist catalysts capable of making hydrogen peroxide behave as an efficient oxidant in aqueous conditions, producing products with excellent purity.
What effects cause deviations from the ideal gas law?
Deviations from the ideal gas law occur due to intermolecular forces between the gas particles as well as the fact that gas particles do actually occupy volume. There is a modified version of the ideal gas law, see atoms and molecules, called the van der Waals equation of state, that uses constants specific to each molecule or atom to adjust for these factors. Deviations from ideal gas law behavior become more important at relatively high pressures and or low temperatures.
What is UV/vis spectroscopy?
Electromagnetic radiation in the ultraviolet and visible region of the spectrum. 40 to 1000 Thz, is higher in frequency, and thus energy, than that in either the microwave or infrared. This makes it a good match for the larger energy level spacing associated with transitions between electronic energy levels. UV/vis spectroscopy can be used to study molecules in any phase. However, it is most commonly used for liquid samples.
What is a mole?
The SI unit used to describe the amounts of chemical, 6.023 x 1023.
Why did Karl Bosch, Germany, and Friedrich Bergius, Germany, win the Nobel Prize for Chemistry?
For their contributions to the invention and development of chemical high-pressure methods. Bosch worked with Fritz Haber on the synthesis of ammonia that today bears both their names, but was not recognized in the 1918 prize with Haber. Bergius developed a process for producing liquid hydrocarbon fuel from coal. Bosch also worked on the so-called Bergius process. After Bergius sold his patents to BASF, where Bosch was working at the time, the Bergius process and the Haber-Bosch process both operate at high pressures, and both methods had significant impacts on human history.
What is PVC, polyvinyl chloride?
if one of the hydrogen atoms on every ethylene monomer in polyethylene is replaced by a chlorine atom. Note that this is not how this material is actually made. You get PVC, or polyvinyl chloride. It's the third largest volume polymer produced each year behind polyethylene and polypropylene. It is a very tough polymer, so it is used to make pipes and flooring among many other things. PVC can also be softened, technical term, plasticized, by introducing small organic molecules, like phthalates, a benzene ring with two esters. Among other applications, plasticized PVC is used to insulate electric wires and to make your garden hose.
What is a carbene ligand?
A carbene is a molecule that contains a carbon atom with two bonds and two unpaired valence electrons. This leaves the carbon atom neutral in terms of formal charge, see atoms and molecules, but still typically much more reactive than a typical carbon atom with four bonds. Carbenes are often found coordinated to metal centers in organometallic complexes. These carbene ligands are less reactive than a free carbene species. And actually you might be surprised to learn that organometallic carbene complexes aren't always prepared from the reactions of free carbenes with metal centers. As an organometallic ligand, a carbene may be either electrophilic or nucleophilic at the carbon atom. See organic chemistry. Carbene ligands that are electrophilic at carbon are termed Fischer carbenes. And those that are nucleophilic at carbon are called Schrock carbenes. A third class of particularly unreactive carbene ligands are termed persistent, or Arduengo, carbenes.
What is an olefin?
A molecule containing a carbon-carbon double bond, also referred to as an alkene.
What fraction of plastics used in the United States are recycled?
In 2008, about 6.5% of the plastic waste generated was recycled. Roughly another 7.7% was burned to generate energy, while the majority of the remaining waste went into landfills. It is interesting to note that, as plastic production has continued to increase, the fraction of plastics being recycled has decreased. In some cases, this may simply be due to the increasing volume of plastic products or to the fact that it is not easy to build a profitable business around recycling plastics.
What is the valence shell electron pair repulsion model?
The valence shell electron pair repulsion model, V-spare, is used to predict the bonding geometry about a central atom based on a set of rules that predicts the repulsive forces between the electrons in chemical bonds and in lone pairs. In this model, two factors are used to predict the bonding geometry: the steric number and the number of lone pairs of non-bonding electrons. The steric number is defined as the number of atoms bonded to the central atom plus the number of lone pairs of non-bonding electrons. Based on these two numbers, the table below predicts the bonding geometry that will be observed about a central atom. It should be noted that this is just a predictive model, and it will not be correct 100% of the time.
What makes a rubber band stretchy?
Rubber bands are made up of long, tangled up, chain-like molecules called polymers. These long chains prefer to be tangled up because it maximizes their entropy, or just the number of ways they can arrange themselves. See Physical and Theoretical Chemistry for more on entropy, or Polymer Chemistry for more on polymers. When we stretch a rubber band, it straightens out these long chain molecules into a state with less entropy. So basically there are fewer stretched out conformations possible than there are tangled up ones. When we release the rubber band, it contracts to a more disordered state. Primarily just because there are more possible conformations associated with the contracted length.
What is endothermic?
A process or reaction that absorbs heat.
What is PS, polystyrene?
If one of the hydrogen atoms on every ethylene monomer in polyethylene is replaced by a benzene ring. Note again that this is not how this material is actually made. You get PS, or polystyrene. Polystyrene is usually the fourth largest volume polymer produced globally, with billions of pounds made annually. Polystyrene can be manufactured into parts, like CD cases, furniture, and eating utensils. Or air can be mixed with the polymer to make a foam used in insulation both for your house and your coffee cup. Styrofoam, R, is a trademark name held by the Dow Chemical Company for foamed polystyrene.
What is a critical point?
A critical point is a combination of temperature and pressure. Values above which a phase boundary no longer exists. There are liquid-liquid critical points above which the two liquid phases become miscible. And also liquid-gas critical points above which the boundary between the liquid and gas phases disappears and the substance becomes supercritical.
What is a spin?
a type of angular momentum possessed by electrons and some other particles.
What is osmosis?
Osmosis is the movement of solvent molecules in a solution to establish an equal concentration of solute throughout the solution. Solvent molecules move from areas of low solute concentration to areas of high solute concentration, which tends to remove any gradient in solute concentration.
What is a calorimeter?
A tool used to measure the heat change associated with a chemical reaction.
What was the first organic chemical ever synthesized in a lab?
Plus urea. In 1828 Friedrich Wöhler was trying to make ammonium cyanate, NH4CNO, but this salt turned out to be unstable. It reacted to form urea, demonstrating for the first time, arguable according to some, that an organic chemical could be made from inorganic starting materials.
What nutrients do plants obtain from the soil?
There are 13 mineral nutrients that plants obtain from the soil, and these are divided into the categories of macronutrients and micronutrients. The primary macronutrients include nitrogen, phosphorus, and potassium. Plants require these primary macronutrients in relatively large quantities and deplete them from the soil more rapidly than others. The secondary macronutrients include calcium, magnesium, and sulfur. Micronutrients are required in smaller quantities than the macronutrients, and these include boron, copper, iron, chloride, molybdenum, manganese, and zinc.
Why is fugu toxic?
Fugu fish is toxic because of a molecule called tetrodotoxin. This molecule binds to the sodium ion channels in nerve cells, shutting down all communication in your nervous system. The toxin is not affected by cooking, so chefs that prepare this dangerous fish have to be highly trained to avoid serving parts that contain tetrodotoxin. The liver, ovaries, and skin can have very high levels of this poison.
What is the atomic radius of an atom?
The atomic radius of an atom is defined as half of the distance between two atoms of the same element held together in a chemical bond. Not surprisingly, These are very small distances. For hydrogen, the smallest atom, the atomic radius is 0.37 angstroms, or 3.7 x 10 to 11 meters.
Can more than one packing arrangement exist for a given chemical molecule?
Yes, this is referred to as polymorphism, and examples are known for most types of crystalline materials, organic and inorganic molecules, polymers, and metals. The way in which molecules pack in the solid state can actually alter some of its properties. Some pharmaceutically active molecules have more than one solid-state structure, or polymorphs. Sometimes certain polymorphs of drugs can be more useful. For example, a specific arrangement could be more soluble, making it more active in the human body. A second polymorph of aspirin, acetylsalicylic acid, was discovered in 2005, but it's only stable at -180 degrees Celsius.
Why did Paul J. Crutzen, the Netherlands, Mario J. Molina, Mexico/United States, and F. Sherwood Rowland, United States, win the Nobel Prize for Chemistry?
For their work in atmospheric chemistry, particularly concerning the formation and decomposition of ozone. Each of these researchers made important contributions toward understanding how atmospheric ozone is depleted through atmospheric reactions. Importantly, each demonstrated ways in which pollution from humans was responsible for depleting the ozone layer. And they did this by learning how atmospheric pollutants caused the breakdown of ozone. This information will hopefully continue to help us protect the ozone layer and the stability of the Earth's climate.
So how then do astrochemists detect H2 in space?
By looking at other parts of the electromagnetic spectrum. Chemists can detect molecules with no net dipole like H2, detected by UV radiation, or CH4, detected by IR.
How is oil refined?
There are several processes that can be used to refine oil. The oldest way is through distillation, which involves heating up the crude oil slowly, allowing the different hydrocarbons to boil off one at a time, and then collecting them as vapors. There are also newer chemical refinement methods that can use a chemical reaction to convert one type of hydrocarbon into another.
Why can't lactose intolerant people eat dairy?
Most every dairy product contains lactose, which is a type of sugar. Specifically, lactose is a disaccharide made up of one galactose molecule and one glucose molecule. Lactase is an enzyme that breaks the bond that joins the galactose sugar to the glucose sugar to form this double sugar. Lactose intolerant people lack the enzyme lactase, so they can't metabolize this particular molecule. All mammals can digest lactose when they are first born. But it is very rare for adult mammals to continue to be able to absorb the sugars found in dairy products. Recent studies have suggested that humans only obtain this ability around the same time they began domesticating animals. This makes it possibly the most recent example of evolution in our species.
What is an adiabatic process?
An adiabatic process is a process in which no heat is exchanged with the surroundings.
What is an anode?
The electrode at which oxidation occurs.
How does the density of matter in outer space compare with that in Earth's atmosphere?
To give a quantitative idea of just how dilute the matter in outer space is, consider that roughly 2.5 x 1019 particles, typically atoms, occupy 1 cubic centimeter, 1 ml, of volume in the Earth's atmosphere. In outer space there is, on average, only one single particle in this same volume. Outer space is a much better vacuum than even the best vacuums ever created on Earth.
Where does all that wax go when I burn a candle?
Why, it burns. The long hydrocarbon chains that make up candle wax are transformed into carbon dioxide and water. Candle wax is the fuel for the flame, the wick just helps draw it up to the flame by capillary action.
What is an isothermal process?
An isothermal process is a process in which the temperature remains constant throughout the process.